Okay, so again, the first part of these notes are on February 22nd videos and February 23rd videos on Google Classroom from when we were out for the snow. So just as a review, because we're going to use this, permutations are when you rearrange something. So it's when the order makes a difference. So like if I'm going to line up people in a row, how many different arrangements I make, order definitely makes a difference. Or if I'm going to pick people to like raffle prizes, and the first person that wins gets $500, and the second person gets $100, and the third person gets $50, then obviously what order you get picked makes a difference. So a permutation is when you're rearranging or you're picking people and it makes a difference as to what order they're picked in. And that's what we had covered, and basic counting principle. To do a permutation, we do that N with the exclamation point behind it. And that's N, an exclamation point is called factorial. So if you had, for example, 3 factorial, that means you start with this number and you go down by 1 until you get to 1, and you multiply all those numbers together. So 3 factorial is 3 times 2 times 1. 7 factorial is 7 times 6 times 5 times 4 times 3 times 2 times 1, which is that number. So a calculator obviously is going to be quite handy here. And then 20 factorial would be 20 times 19 times 18 times 17, all the way down into 1. So, and that would tell you how many different ways you could rearrange 20 people, or how many ways you could rearrange 7 people. All right. So we're going to rearrange some children arranged in a line. I'm assuming I'm going to give you the number. Yeah. Rearrange. We'll do 5. So thinking about lining up to go to recess when you were in elementary school, it made a difference where you were in that line. Everybody always wanted to be first. They wanted to be the very first person so that they could be the first person outside to play at recess. Or at least really close to the front. So how can we figure out how many ways 5 children can be arranged? Thinking about what we did. Say that again? Yeah, that thing we just did. 5 factorial. Grab you a calculator if you haven't yet, because you might be able to do this one without a calculator, but they're going to get bigger. Or use an online calculator for those of you at home. Or your phone. Okay, so it's 5 times 4 times 3 times 2 times 1. How much is it? 120. You wouldn't think that with 5 people that there's 100 different ways, 120 different ways that they could be arranged, but there is. Because you think about it, there's 5 different people. You can also think of this as basic counting principle. There's 5 different people that could be in the first spot. Then once you pick that spot, there's 4 people left to be in the second spot. And then 3 people, so it's also basic counting principle. You can do it either way. It's done the exact same way. Okay, questions? All right. Okay, permutation of N choose R. So it looks like this. It's got a little N in front of the P, a little R after it. And the formula looks like this. That's very important. So this time, it's like you're taking you have 5 kids in your room, but you're only taking 3 of them outside. So you're not choosing all of them. So that's how it's different than what we were doing. So like this problem, we've got 5 letters, A, B, C, D, and E. We want to know how many distinct just means different. So how many different ways can 3 letters be selected and arranged if repetition is not allowed? So like, you could have A, B, and C, or you could have B, A, and C, or C, B, and A, or you might not even choose these 3. You might choose these 3, or these 3, or the first 2 in this one. So if you were actually going to write all these down, it would take forever. And a lot of, you just really have to think about it. So this is a nice formula that does that for us. So permutation, we have 5 letters that we're choosing from. So the bigger number goes on the left. And how many we're picking in choose R, we're picking 3 letters, so the 3 goes here. So this one's the N, and this one's the R. So it's 5 factorial over 5 minus 3 factorial. Notice the 5 minus 3 is in parentheses. So that's 5 factorial over 2 factorial. So 5 factorial we know is 5 times 4 times 3 times 2 times 1. And 2 factorial is just 2 times 1. So we can cancel out the 2 and the 1 on top and bottom, because when you divide something by the same thing, they cancel. So we really just have 5 times 4 times 3. Which is 60.
Okay. So you don't have to write all this down. You can just write down permutation of whatever the numbers are. So you're among 9 people forming a hiking club. Collectively, you decide to put each person's name in a hat and to randomly select a president, a vice president, and a secretary. How many different arrangements or permutations of officers are possible? So what's the big number? What's the N?
9.
9, because we have 9 that we're choosing from.